So to start off, most of what you're going to be doing resembles something like if you were doing 2x plus 6 equals 4x. Let's see here, like plus 8 or minus 8, minus 18, something like that, where you have variables on both sides and you have numbers possibly on both sides. So the way to solve these is that we usually moved the variables to the left, right, by subtracting or adding whatever's on the right-hand side, and then we added, subtracted any number on the left-hand side and put it over here, and that way we had variables on the left, numbers on the right, so we could get something like this, which is negative 2x, and that would equal, it's like negative 24, and then whatever the coefficient of x is, whatever the number attached to x, we would just divide by that number, right? So most of these equations follow that format. Let's see here. So you get like x equals, what, positive 12 in this case. Now the one thing that's going to be different for these problems is that the coefficient for regular equations is usually in front of the x, but you're going to notice that with logarithms it's going to be after it. It's going to be like have like a 2 or a log of 2, and you'll still be dividing by 2. It'll just be after the x, so it's a little different in that sense. So just keep that in mind that it's the same thing if you're multiplying, regardless if the 2 is here or if the 2 is here, you'd still do the same thing and divide by 2, or whatever this number happens to be. So keep this in mind as you're doing these problems, because that kind of dictates, what to do on both sides and so on. Okay, so it's a familiar problem, but you're going to be using all the logarithm rules that we've been using. So if you're adding them, if you're adding two different logs, you can multiply the numbers. If you're subtracting two logs, you can divide the numbers. If you have a power of a log, it becomes a coefficient, from exponent to coefficient. So first of all, you want to look at this and see, can you do this just by changing the bases, right? So for instance, if this was 8, recall that we could just change this to 2 to the 3, right? And it had the x minus 2, and then we'd have x, and then since the bases are the same, you could just solve this equation, right? So this is we've solved equations like this before, but the bases you could always rewrite to be identical. It's like one of the first things we did. So this is always something you want to look for. From this point forward, it might be an easy problem like this. So that's the first thing you look for. In this case, you can see you can't rewrite 6 as a power of 2. So that strategy doesn't work, and you have to do a much longer problem. But I've seen people run out of times on quizzes and tests. They run out of time because they try to do every problem the long way without checking that first. So it's one of those things that if you see a bunch of problems, you're like, how am I going to finish all of these in this short period of time? There's probably some of them that you can do really quickly. You're just choosing a longer way because it's the last thing you learned, right? So don't forget that from the beginning. But if that's not the case, you can't rewrite the bases to be the same. That's why we have logarithms, right? So the first thing we do, just like you can add on both sides, subtract on both sides, you can take the logarithm of both sides. So we take the log of both sides. And then just start using all the properties you've learned, one by one. Like if there's an exponent, that can become a coefficient. Drop that in front, and we'll do it on both sides. Right? So we'll have x minus 2 in parentheses, very important. Right? And then over here, x. And then we'll have the log of the original problem. So we'll have 6 here and 2 here. And our goal, now that we got here, we have no more exponents. So this is where that two-step equation I wrote up earlier comes into play. You want to get all the variables to the left, all the numbers to the right. So right here, there's a variable number all tied together because they're in parentheses. So we're going to distribute this log. And just like I said before, usually what we distribute is in front of the parentheses. With logarithms, usually it's after them, right? So we have to distribute each one of these. So we're going to have the x log of 6 minus the 2 log of 6. X log 6 minus 2 log of 6. And then over here we'll just stay the same, x log of 2. This way we have the x and the number part, the variable and the number part separated. So now we can move things from left to right, right to left, depending if it's a number or a variable. And just like the two-step equations you already know, you could move all the variables to the right and move all the to the left. So at this point, if your work does not match somebody else's, it doesn't mean it's wrong, but they could just choose to do it a different way. And typically, we do move the variables to the left, so that's what I'm going to do. So since this is a variable, I'm going to subtract that on both sides. Right? And since this is the number, the minus 2 log of 6, there's no variable there. That's what I'm going to move to the right side. So similar algebra, it's just the numbers are bigger because they have logarithms in them. So the numbers on the left are now gone. Those are canceled out. Variables on the right are now canceled out, equals 0. So I have only variables on the left, only numbers on the right. You could do it the opposite. That's fine. Some people might look at this like, wouldn't it be faster just to subtract this over here? Yeah, possibly. But, it's just personal choice. All right, so let's simplify this. Now, right here, these have different numbers here, so you cannot just cancel them out, and no, you cannot just do 6 minus 2. All right, that doesn't work. So we just have to rewrite the whole thing. So we have x times log of 6 minus x times the log of 2. And the right-hand side, we have just the 2 log of 6. This is where all those rules come into play. Kind of like how earlier we distribute this in, right? We now want to factor out an x, right? So I have just a single x right here. This gets us closer to having the x equals that we're looking for. Because I have two x's in my equation, and by factoring it out, now I only have a single x. And we can use some properties. If you look back on your notes, you'll remember we had different properties. So if we're subtracting logarithms, that's the same as dividing those numbers. Remember, these are exponents. So whenever you're subtracting exponents, that happened when you divided numbers with the same base. Same thing over here. We could say, well, this 2, let's combine it. Let's put it back as an exponent and make that log of 6 to the second. So that makes this, all the numbers become way smaller. So we now have x times log of 3 equals log of 36. And then we can go ahead and divide both sides by the coefficient of x, which, as I mentioned before, this is x times log of 3, so the coefficients are after the variable, so it's in a slightly different place than we're used to seeing it. And now you can find out, use a calculator, what does x equal, or approximately equal to. All right, and you get what? Let's see here, fraction, log of 36 divided by log of 3. We get about 3.3. 6. And of course, you can check it right over here, plug it in. So 6 to the 1.26 is 6 to the 1.26 equal to 2 to the 3.26. And that's the check. So you get the decimal for both. 9.56. And is that fairly close to 2 to the 3.26? And it is. Off by less than 1% is a good margin. Now, if these numbers are too far apart from each other, use 3 digits, and you'll see the more digits you use, the closer they'll be to each other. So the more you round off, right, and don't take into the precision or the precise answer, those answers become further apart. But if you're within 1% or 2%, you're in pretty good shape. Okay. All right, so that's the process, of course, including the check, because you want to know if you're doing these right. So if you have this tendency to like, I'm not sure if I got the right answer, okay, find out if it's the right answer. It took, 5 seconds. So you'll know real fast if it is or it is not. Let's see here. And so one other thing. I didn't grab everything, but let's see here. So at this point, if you do like I just did on every single problem, you might end up noticing I don't want to do that. Yeah, you might end up noticing that these numbers, like if this was, this is only, 6 squared, but if it's like 5 to the 6th power, it starts being in like the tens of thousands. And then if you have to multiply that by like 17, now you're in the hundreds of thousands or millions or something. So it is possible at this point, instead of simplifying this to log 3 and, combining this, you could just divide both sides by the coefficient, right? And just leave it like this and divide by it, whatever that number is, because we don't really care what that number is. You just have to divide by the same thing on both sides. Log 2, right? And then from here, just say x is equal to this. So it's more typing in the calculator, because you'd have to put 2 log of 6, and on the bottom you'd have to put log of 6 minus log of 2. But you can see it still gives the same answer. So it's nice to simplify and do all this, but if it's too much and the numbers are too big, just divide by the whole term as a whole, and then we'll still get 3.26 and still do your check. All right, so I'll put a big OR here, like that. And then, so go ahead and try this on your own. Check your answer to see if it's the right answer or not. And then when you're ready, you can go ahead and start number 30, either finish 36, right? Or start on 37, start with ABC, do the